Hello, Math 20-1. What I want you to do right now is to pause, reflect back on your Math 10, and see what you remember about graphing. So on page 254, I want you to complete slope, y-intercept, and x-intercept for each of those. Remember how to do that, and then graph each of those lines, and then come back and see if you got it right. Go. So the number that is in front of the x. So remember, the first equation is set up to do y equals mx plus b. Right, Jaden? Okay. So I've solved it for y, which it is. The number in front of the x is the slope, and the y-intercept is the number hanging out by itself. So given that, I automatically have the y-intercept and the slope. The x-intercept, when an equation is written this way, how do you find that, you guys? How do you find x-intercepts in general? Need to go and let y equal 0. When you let y equal 0, and there's a little bit of work to do, you'll find out that the y-intercept is 7.5. Okay. I'm going to go quick, and you guys stop me if something doesn't make sense. Okay. So as you can see, we have the x-intercept, the y-intercept, and the slope. We graphed it using whatever pieces we needed. In equation number 2, it's general form. So remember that, you guys? ax plus by plus c. Ew. I don't want to go through and solve for y. I might if I feel like it, but I can easily find the x and y-intercept. How? Well, I can find the x-intercept by making y 0. And if you make y 0, you get 3x plus 9 and x equals minus 3. I can find the y-intercept by making x 0. And it's really good if you actually show your work so you can remember that. And if somebody wants the slope, like they asked us to do, because we're trying to remember how to do these things, we simply use the slope formula. And the slope for Math 10 was y2 minus y1 over x2 minus x1. Okay? And if I subtract those numbers and divide them, minus 4.5 minus 0, and 0 minus 4.5. Okay, and that's why I like it when you guys write your x and y intercepts as coordinate points, not just single numbers, because then you remember that it has an x and a y value to it. Okay, and then you graph that line. And again, you can choose to use whatever conditions you want, but I don't like graphing decimals. Okay, I don't like graphing decimals, so for me, I'm going to graph minus 3 and 0. Okay, I graph minus 3 and 0, and then I do my slope, which is down 3 and over 2. 1, 2, 3 and over 1, 2. Down 3, 1, 2, 3 and over 1, 2. Okay, all right, so again, review. Urge, line. Oops, come on, make me a line. Okay, and that is line number 2. Okay. Remember this stuff? Hello. I think they remember it. I will. In whatever way you want in green, I'm going to do it in green. I want you to graph the line 4x plus 3y equals 24. Okay, so this line right here, graph that on the picture, and then we will chat. Okay, you can use a sticky note or whatever, but graph that line, and then we're going to talk about shading the right region. Okay, all right, go, and come back when you're done. Whatever method you chose, you should have a line that looks like that. My line has an x-intercept of 6 and it has a y-intercept of 8. And how you get there is really up to you. You could have switched it to y equals mx plus b form, your call, but your line needs to look like that. Now the question is, to shade in red, or whatever color you have, the part of the graph where 4x plus 3y is greater than 24, and in blue, shade the graph where it's this. And the best way to do that is to choose a point on either side of the line. So pick a point on either side of the line and test it. So Jaden has asked us to test The 0.55, you guys. When you test that point, see if it's true or false. If it's true, awesome. If not, then we'll go back to the drawing board. If I test in the original equation, so I'm just going to go black. If I test in the original equation, 4x plus 3y is supposed to be greater than 24. Plug in 5 and 5 and see what you get. When you plug it in there, you get 5 times 4 is 20. Maybe I should show that. 4 times 5 plus 3 times 5 is supposed to be more than 24. Is this true or is it false? 20 plus 15 is 24. I get 35 is more than 24. So the question is, based on the red equation, is that true or false? And the answer is, it is true. Therefore, it fits the red equation. It fits the greater than, so I should shade this red. This part should be red because it satisfies. And if that's the case, do I need to test the other side? No, because clearly the other side is the blue side. This satisfies less than 24. What's the middle? The middle is the equals. And so my dog can walk on the line, my dog can walk above the line, my dog can walk below. Those are the three regions based on that boundary, okay? One last question to see if you're actually ready to fly on your own. So I want you to do question number, oops. Well, one of the things that you guys can kind of read in this part is things that we've already talked about. We talked about broken line and on. You have a really good book. Whenever you're struggling, go into it and look. The one thing I did want to draw to your attention as you go through is I think we've talked about above and below and on and dotted line. That's the one thing that I do want you to say. A line that is on the line is solid. A dog that can walk on the line has a solid line. A dog that is not allowed to be on the line has to be dotted. Where does it say that? I don't know if it does. Okay. But we need, broken right here. So when there's a broken line, you can't be on it. The best point that you could use to test, Jaden picked 5, but the best point you could actually use to test is 0, 0. The only time that you can't use that point is when? In fact, test points never work if they are sitting where? Yep, on the line, right? So why does it make sense? Because it's nice. When can it not be used? When it's on the line, okay? So be careful with that, all right? So before I set you free and fly, I simply want you to do number 1, and I'll leave, okay? So you can choose X and Y intercept, you can do whatever you want, finish off number 1, and you're good to go. So you've had a chance to try it, and if you look, or maybe you're just getting to the shading. So at that point, you've chosen whatever method. I chose to graph the x-intercept, which was 0 and 6. I chose to graph the y-intercept, which was 0 and -2. And so when I plot those 2 points, I get a line that looks like that. And at that point, right, I could, right, and I'm showing more work than I need to. I'm showing how if you wanted to solve it for y, you could and get y equals -1/3 x -2. You don't need to do all this work, right? Pick a method. But if you graph it, you get the black line. So now what you guys have to do is you have to decide, do I shade above the line, below the line, and do I include the line, or is it dotted? Okay. So my suggestion is, you don't know, test the origin. Is the origin, as Sabrina, you said, is the origin part of the line? And no, the origin is right here. So I just took the origin, whoopsie, I took the origin and I stuffed it into the equation. And when I stuff 0, 0 in, it's beautiful. 0 and 0 into the original equation up here gives me 0 minus 0 is greater than 6. And 0 is not greater than 6. So that means it's false. And so I shade the other region. My dog is going to get zapped if he goes standing on the origin. So I shade below the origin. And then you ask yourself, as you do these questions, should it be a solid line or should it be dotted? And why? Yeah, I should look at you. Why? Because you're here. Above, dotted or not? I think it should be dotted too. So as we do these questions, I just put a little summary that you may or may not find useful. That's your call. If you're going to do questions like this, you need to graph a line using whatever method, mx plus b, decide whether it's solid or dotted, use a test point, and then shade the proper area, okay? And away you go for a 5.2 assignment.